We want to write it in terms of what we know. Maybe it's tangent, or maybe it has something to do with tangent. Seems like it does have something to do with tangent. Let's write this in terms, let's write secant x in terms of a function whose derivative we already know. How do you write secant x in terms of either sine, cosine, or what else do we know? We know, yeah, how about that? 1 over cosine. Like that.
So does that make it 1 over negative sine?
Well, what will have to happen is we'll have to use the quotient rule. Have to use the quotient rule here. Where 1 is nice. Derivative of 1 won't be any trouble. But the whole framework here is we've got a quotient of two functions. The numerator is 1, the denominator is cosine x, and we just fit it into the template for using the quotient rule. So we take what's in the denominator, and we write it in the denominator and square it. Cosine x. Square that. While we're thinking about it, write it down again. But then multiply by the derivative of 1. Okay, so that part of the expression is going to go away in a minute. Minus 1 times the derivative of cosine x. And we'll see how this shakes out. Of course, the derivative of 1 is 0. We'll write that down. Cosine x times 0 minus 1 times derivative of cosine x is negative sine x all over cosine squared x. So the numerator ends up being what? Well, I heard a lot of stuff there. 0 minus negative sine x? So just sine x over cosine squared x. This is one way. One could write the derivative of secant x. There are many other ways one could write the derivative of secant x. It's just not the most popular way. When you look in probably the back of the textbook, front of the textbook, wherever all these derivatives are listed, derivative of secant x equals blah, it's not going to say sine x over cosine squared x. It's going to be secant x tangent x, because the idea is it's better without a fraction. Better without a fraction. So although it may not be obvious why one would want to do this, we could write this as 1 over cosine x times sine x over cosine x. The idea being, let's see if we could write it so that it doesn't involve a fraction. And then 1 over cosine x is secant x. And better yet, where it does involve the original function secant x that we're trying to differentiate, times tangent x. So derivative of secant x times tangent x. Reasonably easy to remember. If we can remember that, I'm going to try to resist the temptation to show all the work for this one. ddx of cosecant x. Real close to that. Cosecant x, cotangent x, negative. Yes, it would be negative. So if you can remember one of these, maybe you can remember the other one. It's a product of those cofunctions, but it does end up that sign gets flipped. So somewhere, note card, all 6 of those derivatives, or 6 different note cards, however you like to study that sort of thing. Definitely want to memorize those early and often.